In this problem, we're going to talk about the elastic potential energy. So consider that we have a spring that has a spring constant K and a block attached to the spring with a mass M, and the spring is stretched a distance x from its equilibrium position. Then the potential energy associated with this situation is kx squared over 2. This is the elastic potential energy. Also remember that the kinetic energy of the block will be mv squared over 2. Now let's say that initially we give the spring, the system spring block, stretching of x0. This is the initial value of the stretching with velocity v0, initial speed v0. And our goal is to find, using energy methods, what is the maximum value of the velocity v, and in question B, what is the maximum value of the stretching x. Okay, so what I'm going to do here is to use conservation of energy. So notice that the total initial energy is equal to the total final energy, and the total initial energy is the elastic energy, 1/2 of k x0 squared plus 1, the kinetic energy, which is plus 1/2 of mv0 squared, and this is equal to 1/2 of the final kinetic energy, that's one of the final elastic energy, 1/2 of k x squared plus 1/2 of the final kinetic energy, mv squared. Now, if we want v to be maximum, then we want x to be 0. So this term here is cancelled. And I can say that because since the energy is constant, so this here is just a number, then for v to be as great as possible, then x has to be as small as possible. And the smallest possible value of x squared is 0. Okay, so the 2's cancel out, and we have the following equation. 1/2 of kx squared, x0 squared, I'm sorry, and there's no 1/2. So kx0 squared plus m v0 squared is equal to mv squared. So v squared, if we divide both sides by m, is equal to v0 squared plus k over m x0 squared. So v is the square root of v0 squared plus k over m x0 squared. This is the value, the maximum value of the speed. And in question B, we have to find the maximum value of the stretching. So in this case, v must be 0. Okay, so the kinetic energy is minimum, so that the elastic potential energy is maximum. So we have 1/2 of kx squared plus 1/2 of m v0 squared is equal to 1/2 of kx squared. The 2's cancel out, and I will divide both sides by k. So we have x0 squared plus m over k v0 squared is equal to x squared. So x is the square root of x0 squared plus m over k v0 squared, which is the answer to our exercise.